Hello again, people I like. We're still on chapter 1.3, video E. There's going to be 6 videos by the time I finish this. Okay, so let me read the problem to you. Problem says an equation of the terminal side of an angle theta in standard position is given with a restriction on x. Sketch the least positive such angle theta and find the values of the 6 trigonometric functions of theta. You can also refer to example 3 in the book. Wow, that was a mouthful. So right now I have no graph, right? So I'm going to graph this line, 2x plus y equals 0. Of course, I really don't know how to graph that. I know how to graph y equals mx plus b. So I'm going to do that. I'm going to change this form into y equals mx plus b, okay? I'm going to do that, I'll do that in this corner over here. 2x plus y equals 0, and I just want to get y by itself, so minus 2x minus 2x. I get y equals negative 2x plus 0, okay? And I put that negative 2 up there a little bit so I can say negative 2 over 1. Cool. And I kept the plus 0 so that I know that that is my y-intercept. Okay, so this is handy. There's my y-intercept. And then to graph my line, I'm going to go down to 1, 2 over 1. And then I'm going to do that again. 1, 2 over 1. 1, 2 over 1, because I know my slope is negative 2 over 1, okay? So there's my line. Now, the line actually does keep going in this direction, right? However, because of this, x being greater than 0, I'm going to stay on the positive part. So here's where x is greater than 0 on the x-axis. I'm going to ignore that and focus on this, okay? So the location of my angle theta is, here's the starting position. It goes around to there, okay? And the coordinates of this point, actually I can just pull it right off my graph, is this point is at positive 1, negative 2. Okay? So I'm going to go back to the book and see what they are even asking for. Okay, they want all 6 trig values. So that means they want the, I forgot to call this theta, that big old angle. They want the sine of theta, cosine of theta, tangent of theta, secant theta, cosecant theta, and cotangent theta. We actually did that in a previous video, but I'm going to go ahead and do this here, all right? I'm going to lift this up so I have a little bit more room here. Sine of theta, if you recall from your notes, is the y-coordinate. Negative 2 over, oh, wait a minute. We don't have the radius. What is r? Oh man, I knew that was going a little too easy. So I'm going to pause right there and find out what r equals, okay? I'm sectioning this off like it's my scratch paper, okay? R squared equals 1 squared plus negative 2 squared, right? So r equals the square root of 5. Huh, ugly. All right. So the sine of theta is negative 2 over the square root of 5, okay? Now, having a square root in the denominator is just considered ugly. All right. So we're going to rationalize that denominator, meaning I'm going to take that irrational number and turn it into a regular rational number. So I'm going to multiply this by square root of 5 over the square root of 5. And my final answer for the sine of theta is going to be negative 2 root 5 over 5. Okay. I can do that because this quantity is equal to 1, right? Anything divided by itself, as long as it's not 0, is equal to 1. Okay. So that's it for sine. Cosine theta is going to be the x-coordinate, which is positive 1, over r, which is still square root of 5. And I'm just going to do the exact same process there. I'm going to multiply by root 5 over root 5. And I'm going to get square root of 5 over 5. Cool. And I'm going to do tangent. Is the y-coordinate negative 2 over the x-coordinate, which is 1. That's just negative 2. Okay. Now for secant, cosecant, and cotangent, it's just a bunch of the inverses of these. I'm going to leave those up to you. Okay. I hope that is helpful. And let's go on to the last video and the last problem.